going to throw this guy out, and we're going to finish solving it for y. So we're just going to be doing a differential equation here and ultimately looking at some slope fields. So whenever we do these, the two things that we pretty much always need to do is look at our slope field and then find a particular solution is almost always what they're going to ask us to do. Occasionally, they'll also ask us for parameters on those slopes. So let's jump in and take a look at this one. So we've got the differential equation dy over dx is equal to y minus 1 over x squared. Obviously, in this case, x cannot equal 0 because we'd be dividing by 0, and that doesn't work. So what we're going to do first is look here at our field. Now, instead of having 12 points, the first thing you're going to notice, of course, is that x equals 0. There is no points. Why? Because they know that we cannot have any slope there because the function is undefined. So they're not going to ask us for any of those. Now, the next thing we probably want to do is take a look at when this whole thing is going to be 0. Well, based on our function up there, and maybe I'll rewrite it right here for us to make it easier, we can see that this whole thing is going to be 0 whenever the numerator equals 0, which means anytime that y equals 1. So if y is equal to 1, we're going to get a horizontal slope because the whole function here is going to be 0. Then what we can do is see if there's any others. In this case, there's no other real interesting things other than the fact that, like we've already established, x cannot be 0 because it will be undefined in that line. So the next thing we want to do is start working out what these other 6 points would be. So if we go to this one here, we're going to make it so that y is going to be 0 and x is going to be 1. Well, if we're dividing by 1, that's not going to change anything. And so we're literally going to end up putting in the point here that 0 minus 1 over 1 squared, which is, of course, just negative 1. So we would have a slope of negative 1 here. Now, we're going to have an interesting thing going on here because it is over x squared. If x is negative 1, it's going to be exactly the same because we're going to get 0 minus 1 over negative 1 squared. Well, that negative 1 squared is simply going to become 1 squared, or 1, just like the first one. So that's going to get the exact same slope for us, right, of negative 1. That actually looks a little bit too steep, doesn't it, for negative 1? Negative 1 should be coming down on like that line like that. So there we go. That's a little better. Okay, and if we make x equal to 2, that is going to change things. Y is still 0, so we're going to get 0 minus 1 over 2 squared, which is going to give us negative 1/4. Negative 1/4, of course, is going to be something that is much less steep. We're basically looking for something that's like connecting from way over here, so it's going to be very, very, very shallow in its steepness there, okay, or its slope. So now what we want to do is look at these ones up here. Now, usually things are kind of mirrored on these, meaning that if we look up here, we can probably infer that this is going to be positive slopes where these were negative. But again, we always want to double check that, never just assume anything. So let's start off with the two that are going to be the same because, again, it doesn't matter if x is 1 or negative 1. Once we square it, it's just 1. So if we go here, we're going to end up with 2 minus 1 over 1 squared, which becomes just 1. Okay, so this is going to have a positive slope of 1. And likewise over here, it's the same, 2 minus 1 over negative 1 squared. Well, that negative 1 squared just becomes 1, which means the whole thing is 1 again. Okay, this one we can probably guess is going to be 1/4 based on the way that this thing is lining up, but let's again always confirm. So we're going to get 2 minus 1 over 2 squared. This indeed is going to be 1/4. So we're going to be going back roughly from here, aimed sort of like that, nice and shallow in its steepness, okay? So there's our 9 points that are going to go into our slope field. Then from there, just like I said, typically the next step is to ask us for the particular solution. Because we have an initial condition, it allows us to find what that c value would be, which of course is the thing that moves it around within this slope field. So we're going to start out by just giving us that actual equation again. So it was dy over dx. I have it written down here. What was it again? Nope, I don't have it written down. I thought I did have it written down. Y minus 1 over x squared. That's what it was. y minus 1 over x squared. Now, whenever we're doing this, obviously we can't integrate if we've got the y and x's right on top of each other, or at least not easily. And so what we want to do is we want to get the dy with the y's and the dx with the x's. That allows us to actually integrate this thing well, just allows us to integrate it. So what I'm going to do there is I need to essentially, in this case, actually cross multiply. I'm really, just moving the dx over to this side, which means I'm multiplying both sides by dx. And then I'm going to divide both sides by y minus 1, because that moves things to the right sides. Now on the left side, I've got dy over y minus 1. And on the right side, I've got dx over x squared. Now that I've got them separated, I can go ahead and I can integrate these two things. Okay? When I integrate this, anytime you see something just to a single degree on the denominator, we know that that's going to be a ln. Hopefully, at least you know that by now. And so this is going to be the ln of the absolute value, probably should make that a little bit longer there, of the absolute value of y minus 1, and that would be plus c. That's going to be equal to, over here, you can probably, it might be easier to kind of think of this as x to the negative 2 in terms of you working out the integral, okay? Because if we do that, we would add 1 to it, which of course is going to be x to the negative 1, and then we would divide by our new coefficient, which is just going to be dividing by negative 1, and then we would add c. Now, when we get these c's, the other thing is you don't usually want or don't need to write them like this, because ultimately what we would do is you can think of this as being like c1 and this is c2. So if we subtract c1 from both sides, we're effectively just going to get like c3. And so usually what we do is we just kind of combine these two constants as this new one that is what we're then going to use in order to solve. So if I rewrite this now, I've got the ln of the absolute value of y minus 1, okay? And it's equal to negative 1 over x plus c. And we're just treating that c as our new c. Then what we want to do is use our condition that we had there. So we're going to plug in x equals 2 and y equals 0. So when I do that, I'm going to get the ln of the absolute value of 0 minus 1 is equal to negative 1/2 plus c. Now here, the reason we have to do the absolute value is because we can't take the ln of a negative number. And if we see this, the ln of negative 1 is really the ln of 1. And hopefully by now you know that that is 0. So 0 is equal to 1/2 plus c. We're going to move over that 1/2 and get that c is just 1/2. That allows us to now rewrite our equation in such a way that we have that worked out. So once again, we're going to go the ln of the absolute value of y minus 1 is equal to negative 1 over x plus 1/2. Okay? Now, in order to get rid of this ln, because we can't really do that, what we're trying to do now is we need to solve for it in the form of y equals something. Okay? So we need to get rid of the ln. And the best way to do that, or only way to do that, I should say, is to actually raise the whole thing. I'll use like a different color bracket to kind of signify this, to that, like raise the entire left side to the exponent of e. And we're going to do the same thing over here, okay, on the right side. Now, why are we doing that? Well, we're doing that because that's going to make those two cancel, okay? And so we're going to be left with just the absolute value of y minus 1 is equal to, and this might be easier to kind of simplify this. And so if we just kind of think of doing that off to the side here, we need a common denominator. So we would multiply this whole side by 2 and this whole side by x over here. Okay, so if we multiply that, we're going to get negative 2 plus x, and now the whole thing is over that common denominator of 2x. It's probably easier for us to think of it this way, okay? Rather than having like two separate fractions or exponentials there. Now, once we get it to this point, what we need to realize is that this absolute value could go one of two ways. It could be positive, it could be negative. So the first example is that everything in there just stays exactly like it is. So we get y minus 1 equals e to the negative 2 plus x all over 2x, okay? Or the other option is that this whole thing could be negative, meaning basically we flip the sign. So the y becomes negative, the 1 becomes positive. I like to write the positive term first. I just find it a little bit easier. And then it's going to be equal to the exact same thing. So e to to the power of negative 2 plus x over 2x. Now, the next thing we need to do is just confirm that these meet our initial condition. And our initial condition was the point 2, 0. So if we plug in 2 and 0 into here, it should work, okay? If it doesn't, we've got a problem. So if we look here, that's going to be negative 1. Over here, we're going to get e to the, let's see, negative 2 plus 2 is going to be 0 over, not 0, over 4. So 0 over 4. E to the power of 0 is the same as anything to the power of 0, which is 1. Well, that's not true, is it? So this one doesn't work, okay? Because f of 2 does not equal 0 on this case. Now let's check over here. 1 minus 0 is just going to be 1. And then we're going to get the exact same thing. This doesn't change at all. So it's e to the power of 0 over 4, which is just 1. This does work. So f of 2 does indeed equal 0 for this case, okay? That being said, then what we need to do is just use this one here. We're going to throw this guy out, and we're going to finish solving it for y, which of course just means we need to move the 1 over and also change the sign. So we'll do that now. So 1 minus y is equal to e to the negative 2 plus x all over 2x. And then we need to move that 1 over. This part now should be like child's play, easy algebra for you. So e to the negative 2 plus x over 2x minus 1. And then, of course, we need to flip the sign, which means we're just going to change the sign of everything. And again, I like to write my positive term first. So 1 minus e to the negative 2 plus x over 2x. All right, and that would be our equation right there, or our specific solution to the differential equation. So hopefully that helps, guys. As you know, I'll be putting these out every week, so I'll see you around.